Hello YouTube, this is UMilzo3. In the previous video, we basically had more of a chance to discuss other primitive data types in Java, right? We were talking about longs and shorts, and we didn't really talk so much about floats, but if you were inclined enough, you could go ahead and go to blackle.com and study this documentation on your own, right? It amounts to typing 3 words into Blackle or Google and clicking on the first link, and it would tell you about floats, which are like doubles, but they can only hold much smaller numbers because they take up much less space in memory. They're characterized by having way fewer bits. But anyway, what we did is we looked at some different examples with longs, ints, and then also I think we had a short, right? We looked at least one of the static methods from the short class. And this is all documentation that at this point, after 61 lessons, you should be comfortable Googling on your own, right? But we created 2 one-dimensional arrays. One of them was strings and one of them was longs. And then we created a hash map, right? And we basically just created key value pairs that was just linking each of the strings in this array to each of the longs in this array, right? And so we just added those key value pairs and then we printed each of them. And then we said basically, is it still a large number if we divide the largest possible long by 2 and then subtract the largest possible int? And the answer was yes, we still had a large number on the console, but instead of talking so theoretically about this, I guess we could go ahead and run it again. So we can go ahead and just compare the code with the output, right? And so we just printed the 3 things in the dictionary, right? So the largest long is a really large number. The largest short, not such a large number, right? But if we divided the largest long by 2 and subtracted the largest int, you would still get an incredibly large number, right? So shorts cannot hold values very large. You need to accept a string representing a smaller number. And in the context of that, we were trying to print short.decode of 50,000. And we said that the decode static method of the short class accepts a string and tries to return a short, right? But this 50,000 will be too large. But what if we just said 15,000, right? So that's less than short.max value. So maybe it would not have a problem, right, with that. So it would just say 15,000, right? So hopefully that's clear to you. And then so only the try block would run, but not the catch block. But we would still run the finally code. We would say clearly the short class provides a static method called decode that accepts a string object. And then we also talked about this overloaded replace method in the hash map class. And we said that if you have a replace method with 3 arguments, basically the first one is a key, and the second one is some potential original value that was associated with the key. And the third argument is a new value that you'll associate to the key only if the key originally had the original value in the second argument, right? But what we saw is that for the largest int, right, in this dictionary, the largest int was getting assigned to integer.max value, which is like 2 billion. It's not negative 277, and therefore we would not replace the value associated with largest int to be 19,000, to be math.apps of negative 19,000. We would not do that because we only make the replacement if the value was currently q. And then if we say system.out.println of mydictionary.get of largest.concat of i.to lowercase plus nte.substring of 0, 2. And so that would just be largest in. I was just trying to play around with some more instance methods that belong to the string class. But then we would still get 2,147,483,647, which is the same value that was associated with the largest int string at the beginning of the method, right? And then we created another dictionary, another hash map called cookie, and we added 2 key value pairs to it, right? And so this key sort of coincides with the key in the other dictionary, but that's okay, because when we call this void method called putAll, which belongs to the hash map class, we say mydictionary.putAll of cookie. So for some particular hash map, you say hash map.putAll of other hash map. And basically it adds the other key value pairs from the other hash map to the current hash map that you called the putAll method putAll method on. So then you say for each of the strings s in mydictionary.keyset, system.out.println of key, and then whatever the key is in the dictionary, and then value, and then mydictionary.get of s. So what value is associated with that particular key. And so that's why these 5 elements that were in the dictionary, these 5 key value pairs, show up in this particular format. And we said that sets are characteristically unsorted. And so that's why these key value pairs don't show up in any particular order. And we could see a couple more examples of that, but you just want to be familiar with the documentation here, and you want to understand that if you try assigning longs to ints, you could have problems with that. So what if you say int q equals long.maxValue minus 100, right? And then it looks like it's already going to have an issue here. So it says possible conversion from long to int, and you can see there's already a problem with that operation. Okay, and so hopefully that's clear to you. But then what if we said something like long q equals long.maxValue minus 100? So that's going to be a pretty freaking large number. And then what if we said int of q? And so we just try to explicitly cast the long into an int, and then so we can go ahead and compile it, and then we can go ahead and run the which method was that in? So that was in the I guess that's in the vector function method now. So we call vector function, and we get negative 101, which doesn't seem right, because is long.maxValue equal to -1? No, it's not. And so this is sort of a strange result. The same thing would happen if we said int q equals integer.maxValue minus 30,000, right? And then what if we say short of q? So this would be another issue where if we try to explicitly cast to a data type that cannot hold a number that large, then there would be an issue with that. Okay, but I'm sort of mistakenly saying long instead of large, but in a way they're sort of the same thing, because you have to think about these bit strings, right? These zeros and ones that are keeping track of the number, right? And so larger numbers require longer bit strings, right? And so if you call the vector function, now you get negative 30,001, which is probably not what we're supposed to be getting here, right? And then so the same thing could happen with floats, right? And so we said that the difference between floats and doubles is that doubles have much higher precision. They can store much larger numbers, and we could go ahead and study that, right? Because if you say float.maxValue, that would be 2 minus 2 to the negative 23 times 2 to the 127, 2 to the 127. And 2 to the 127 is a pretty large number, but then if we go to double Java API, and then we go ahead and click on this link, we would go ahead and look at the max value, and it says 2 minus 2 to the negative 53, 2 minus 2 to the negative 52 times 2 to the 1023, which is a much larger number than float.maxValue. And you could verify that with a simple Boolean. You could say system.out.println of short.maxValue. I guess we're talking about floats now, so float.maxValue less than double.maxValue, and presumably that would be true, right? And so then anyway, you could go ahead and run it, and you would get a true Boolean here printed on the console. So hopefully that's clear to you. But you can study these different operations, right? And there's different constants that these classes provide, right? They don't just provide methods for working with longs and ints and shorts and floats and doubles, but they also provide fields, right? So what if you wanted to know how many bits a double represented? So you could call double.size, and we could go ahead and do that quickly now. We could say system.out.println of double.size minus float.size. So we want to know the number of bits that's required to keep track of a double minus the number of bits that's required to keep track of a float. And that will be a positive number because we're saying that doubles have more precision. So that'll be 32. So that's why doubles are able to keep track of much larger numbers. So hopefully that's clear to you. What we're going to do in this video is talk a little bit more about vectors, right? And so I guess I don't already have it. So then what we're going to do is we're going to say vector of type object, my vector equals new vector of type object. And what we're going to do in this video is talk more about iterators, but then we're also going to talk about something called an enumeration, which is like an iterator, but a little bit worse. Okay, but I saved it for the end of the curriculum because you don't really need it a whole lot in computer programming, and it's kind of an arcane topic that doesn't really fit into the context of like a college course. Like you wouldn't really see a question about an enumeration necessarily on an exam. But anyway, what we're going to do, similar to the previous video, we're going to add different data types to this vector of objects, because we said that every class is a subclass of vector. So, or of object, excuse me, of object. So it is okay to add subclasses of object to the vector of objects. So hopefully that's clear to you. So that would add an integer, right? And then we could say my vector dot add of 72.7, and then we could say my vector dot add of sup. Okay. And then what if we wanted to create an instance of this example class? So we said by default, every class gets a blank default constructor. Okay, you can create an instance of a class, but nothing happens unless you use it. in some meaningful way, okay? But it's kind of hard to use an instance of a class in some meaningful way unless you do something with it, right? Like you use the instance variables of it or something like that. But then you could say, what if we say example E equals new example? Okay, so that just creates another instance of the class, right? And then we could say example F equals new example, right? And then we could say my vector dot add of 0 E, okay? And then we could say my vector dot add of 0 F. And so then we could go ahead and print the elements in the vector, right? And so then I guess after doing this, we would have F at the beginning at index position 0, right? Because that was most recently became the element at index position 0, okay? But immediately after that, we would have E, right? Because that was like the old element being added to the beginning of the vector. And then I guess we would have 15 and then 72.7 and then sup, and then yeah, that would be it, right? And so essentially, what we could do is we could iterate through. And so we could say iterator of type object, and then you could say vector parse equals my vector dot iterator. Okay, so it's just calling an instance method called iterator on the particular vector. So just like array lists and linked lists and stacks and queues and sets can have iterators, so can vectors, right? And then you could say while vector parse dot has next, what we're going to do is we could say system.out.println of vector parse.next instance of objects, right? And so we would be expecting each of the elements in the vector to be an instance of the object class. And so then if we go ahead and run it, which method was that in? I keep forgetting. So this was in the vector function, right? And so we get true for all of them, right? We get true for all 5 of them. What if we ask if it's an instance of the example class, right? And so that would presumably only be true for 2 of them, right? And so then if we go ahead and call vector function, then that's only going to be true for F and E, right? Not for 15 or 72.7 or sup, right? What if we ask if it's an instance of the string class, right? So that's only going to be true for 1 of the 5 booleans, right? We get false, 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 true. So hopefully that's clear to you. But that's an example of vectors, right? And we said that vectors have a lot of the same methods that array lists do, okay? And we said they're very, very, very similar, okay? They're essentially identical classes, okay? And we said there's one subtle difference, and basically what we said is that vector is synchronized, okay? So if a thread-safe implementation is not needed, it is recommended to use an array list in place of vector, okay? So basically when we were talking about threading and we were talking about the runnable interface in the thread class, if you're trying to do concurrent programming where you're trying to operate on a vector multiple times at the same time, then you should use a vector, okay? But if you don't need a thread-safe implementation, then it's better to use an array list. But the point is that the vector has a lot of the same methods that the array list does. In fact, I think it's probably the exact same set, but it's all the same remove methods, and you can call .get of a particular index position, and then you could see if your vector contains an element, right? We talked about, you know, array list contains of X, returns true if X is in the array list. Same thing with linked list, right? Same thing with vectors here. So hopefully that's clear to you. And then you could also clear the entire vector, right? And then you can also call iterator on a particular vector as well. And then you can also set an element at a particular index position within the vector. You could get the number of elements in the vector. Okay, so hopefully that's clear to you. And we've already gotten an understanding of iterators, right? And we said that an iterator is basically a structure, or it's an object that's capable of iterating through a particular data structure, right? And it just provides these helpful methods like has, next, and next. And it's a pretty clear and concise and efficient and clean way to iterate through the elements in a particular data structure. But in this video, I wanted to basically talk about one more method that we have available for iterating through the elements in a particular data structure. So it's called an enumeration, okay? And so basically it is going to iterate through elements one at a time. And so it's going to, methods are provided to enumerate through the elements of a vector, okay? And so enumerations are also used to specify the input streams to a sequence input stream. Okay, but anyway, the functionality of this interface is duplicated by the iterator interface, okay? Iterator adds an optional remove operation. So remember in previous videos, we were talking about how if you call iterator.remove, it's a void method that basically has the effect of removing the element that you just called .next on, that you just referred to with .next, from the data structure that the iterator is based on, okay? But the enumeration class that we're studying now, the enumeration interface, doesn't have, it does not have a remove method, okay? So it says, in addition, the iterator interface adds an optional remove operation, has shorter method names. So new implementations should consider using iterator in preference to enumeration, but you have to think about these two interfaces being very, very similar. And so basically it just has a has next method and a next method, but they have slightly different names. And so we're going to practice with calling an enumeration on this vector rather than calling rather than calling an iterator on it. So what we're going to do is we're going to say enumeration of type object, and then we can say vector enumerate or something, okay? Or you can just call it W, okay? You can just call it something short, and then you could say my vector dot enumerator, I think. Okay, so that's not correct. So let's go ahead and think about what we would do to fix this. Well, I guess I should rewind a little bit and talk about how to use an enumeration. So enumeration is like an iterator, but it does not provide a remove method, which would remove the elements from the data structure. So it just basically has next functionality to check if there is another element in the data structure, and then also next functionality to, return the next element. Okay, so we're going to basically play around with this, but it's going to be very similar to how we used an iterator. But the point is that an iterator should be used in preference to an enumeration, but I wanted to bring it up anyway. And so we're going to use these two methods. But the first thing that you have to do is import java.util.iterator, right? Or to .enumeration, right? And so you would have to make sure that's imported at the top of your class. And so we import java.util.enumeration, just like we had to import java.util.iterator. And then you need to create an enumeration object based on the data structure. Okay, so maybe on a vector, maybe on an array list, maybe on a linked list. But then what we're going to do is we're going to say enumeration E equals, and then we're going to say my vector dot elements. Okay, and this is how you do it. Okay, so basically we would say enumeration of type object. Okay, and I guess we already called something E, so let's call it enumeration of type object X equals my vector dot elements. And so this is how you would set it up. So you would say enumeration of type, and then X equals data structure dot elements, just like we called dot iterator when we're trying to create an iterator. Okay, and then we're simply just going to call these two methods, and we're going to see how they work. And so you would say while X dot has more elements. What if we want to count the number of elements in the vector? So we could say int count equals 0, and then we could say while X dot has more elements, we could just say count plus equals 1. Okay, so hopefully that's clear to you. And then we could say basically object current object equals X dot next element, right? So you just have to understand how these methods are spelled in the enumeration interface. But the point is that you would be able to go ahead and print out each of the objects, right? So you could print out current object, but since example has no toString method, we will just get the hexadecimal representation of the hash code of F and E. So hopefully that's clear to you, but we could print out each of the next elements. But this is analogous to x.next, if x were an iterator, right? And then this is equivalent, analogous to x.hasNext if x were an iterator, okay? But the point is that enumeration does not provide a remove method, a void remove method, which would have had the effect of removing the element, that particular element that you just called next on, from the data structure that the iterator is based on. But with an enumeration, we don't have that functionality. But what we're going to do is we are going to go ahead and call the vector function static method, and I can quickly show you the output here. So we would just print the hexadecimal representation of the hash code of those two instances of the example class, because F and E are the first two elements in the vector. And then we would get a 15 because integer has a toString method. We just print the int, and then 72.7 and sub. But the point is that an enumeration can be created instead of an interface, but you would want it instead of an iterator, and an iterator would be preferred, but enumeration is another technique that you have available to yourself. Hopefully that was interesting from UML03. Thanks for watching, and please subscribe.